Hi students, this video is a lesson on adding, subtracting, multiplying, and dividing complex numbers. As an FYI, for slides that have a lot of writing, please go ahead and hit pause to be able to copy it all down. So the first slide explains what a complex number is. Remember we talked about imaginary numbers. Imaginary numbers are numbers that have I in it. So this would be our imaginary part and this our real part. So a complex number is a number that has both a real and a complex part. A and B are real numbers, however the I makes this imaginary. So we call A the real part and BI the imaginary part. Make sure you write all this down. So what we're going to go ahead and do now is work on adding and subtracting imaginary numbers. So I'm going to pick up with number 11 because the last video, if you watched my video instead of Mr. Davidson's, the last problem we did was number 10. So let's take a look at adding 7i plus 9i. When we add 7i plus 9i, really what we need to think about is adding like terms. Similar to as if this was, say, 7x plus 9x, we would recognize that since both terms have x to the first power, that makes them like terms, and then therefore we would simply add their coefficients, 9 plus 7 being 16, so that would be 16x. The rule is not any different for adding and subtracting imaginary numbers. We simply add or subtract the real part of each expression. So 7 plus 9 is 16, and that would just be I, 16i. Next, for this next one here, negative 5 plus 6i plus the quantity 2 minus 11i. Recognize that we do have a complex number because we have a real and an imaginary part. Similar to how we would add like terms for any other polynomial expression, we'll do the same thing here. Because we're adding, there's nothing we need to worry about in terms of distributing here to both of these terms. However, we could rewrite them and think of this as a negative or positive 1 rather being distributed. So this would be plus 2, and then a positive times a negative 11i would give us minus 11i. Then we just want to identify any like terms, so we would want to combine our constants here. And let's remember that in a complex number in the form a plus bi to always list our real parts first. So combine negative 5 with 2 and you get negative 3. Then combine our 6i with negative 11i. 6 minus 11 would give us negative 5i. And that would be our answer. Next, we're going to look at subtracting. Similar to here, where I illustrated that we could think of this as distributing a positive 1. It's very important when subtracting to consider distributing this minus sign, or think of it as distributing a negative 1. And that's actually going to change the signs of both terms in the second binomial. So we keep our first two terms, and then negative 1 times 4 would give us minus 4, and negative 1 times positive 2i would give us minus 2i. Then combine like terms. 2 minus 4 is negative 2. And 3i minus 2i is positive 1i, so we'll put plus I. And we're through. And that's adding and subtracting complex numbers. Hit pause if you need to go back and review any of that. So next on our slide here it says, to multiply imaginary numbers or an imaginary number by a real number, it's important first to express the imaginary numbers in terms of I. So what we mean by that is if we end up with I to a larger power, we should remember what we learned about I squared, I cubed, and I to the fourth and simplify those. So press pause to make sure you write that down. This next slide we're going to multiply. And you'll recognize that the rules of multiplying fall right in line with multiplying any other polynomial expression. If we were to multiply 47x times 2, then we're allowed to multiply 47 times 2, which would give us 94, and then we just put the times x. Sorry about that. So same thing here. 47 times 2 is 94, and we include our I, 94i. Next, we've got 2i times the square root of negative 5. So like the last slide talked about, we have to express imaginary numbers in terms of I. So if we see the square root of negative 5, we should remember from the previous lesson that that means we can take out an I, and that would give us I square roots of 5. Now we want to multiply the numbers on the outside. 2i times I gives us 2i squared. But that means we need to remember the value of I squared. So just to recap, if we have I, we use I, but if we have I squared or I cubed or I to the fourth, we have to remember those. So do you remember from the video, I won, but the 2 in the middle are negative. So if we see I squared has a value of negative 1. You definitely need to remember that. So we're going to substitute negative 1 for I squared. Then multiply 2 times the negative 1, which would give us negative 2 square roots of 5. And we're going to do one more simple multiplying problem. So we've got the opposite of the square root of negative 3 times the square root of negative 7. So remembering what we did in the previous problem, because of this negative, we're going to put I out front and make our radicand positive. We'll do the same thing here with the square root of negative 7. Put an I out front, make that positive 7. Then we can multiply what we have left. So we always multiply what we have on the outside together. So negative I times positive I gives us negative I squared. Remember, when you multiply radicands, if they're numbers, you can just multiply them together. So 3 times 7 would be 21. What we do need to remember, however, is that I squared has a value of negative 1. So I'm going to substitute negative 1 for I squared. You can see now that we have two negatives, a negative times a negative, which actually makes us a positive 1 square root of 21. So I'm not going to put a plus 1 out there, it's understood. But my answer would be the square root of 21. Now remember that if you can simplify, if you can break down 21 into factors where you can find a pair of factors, then you should do that. But because 21's its factors are 3 and 7, both of which are prime, we will not find factors, pairs of factors. So what I'd like for you to do is try next. We're going to take out the negatives and just try these. If we've got 3i times 4i, we can go ahead, and you can pause at any time and try these and then hit start again to check your answer. We multiply 3 times 4 together, giving us 12. We multiply I times I together, giving us I squared. But then we have to remember that I squared is negative 1. So when we substitute, we'll have 12 times the negative 1, which is negative 12. The next one we have is the quantity 7i squared. Be careful of this and remember that exponents represent repeated multiplication. So this is actually 7i times 7i. 7 times 7 is 49. I times I is I squared. We will substitute negative 1 for I squared, which results in a product of negative 49. All right. I'm going to write down a couple of them and ask you to hit pause and try these out. So hit pause at this time, write these down, and do your work, and then hit play again to check your answer. All right, hopefully you got those two values. Next, we're going to move on and learn how to multiply two binomials that are complex. Oops, that should be 4 plus 3i times the quantity, I wrote that all wrong, 4 plus 3i times the quantity 7 plus 2i. So we are going to apply the double distributive property. And remember, if you prefer, you can do a box. But 4 times 7 gives us 28. 4 times positive 2i gives us positive 8i. 3i times 7 gives us 21i. So you can see with multiplying, we really treat it like it's any other variable, like x. We just have to remember to substitute later if we can. 3i times 2i would give us positive 6i squared. But what we need to remember here is that I squared has a value of negative 1. So when we substitute negative 1, 6 times negative 1 is negative 6, which can then be combined with our constant value over here of 28. So 28 minus 6 is 22. Please remember to always write your real part first, so the number. Then put the imaginary part. When we combine 8i and 21i, we get 29i. And that's our answer. So I'm going to give you one to try here. And if you would, press pause, and then you can come back and check your answer. So press pause now and write this down and try it out. Congratulations if you got it right. There's one last one I'm going to talk about before I move on to talk about the conjugate, which will help us with dividing. Go ahead and hit press pause now and try this one. So if you take a look at this one, what happened was actually when we started, it looks like factors of a difference of squares, meaning you have two binomial factors that look the same with the exception that one is a sum and one is a difference. So what happened was our middle two terms canceled out, but we ended up with an integer here on the end when we substituted negative 1 for I squared, so we actually get a value that's a constant. And that will always happen when they appear to be differences of squares. Okay? So the next thing I'm going to do is talk about division, but what I'll do, because this video is already 14 minutes, is stop it here, and then there will be a second video on dividing complex numbers.